Hello and welcome back to the ABB Process Automation Podcast. Today we are returning to one of our most fascinating topics, the key role of automation in the daily operations of industries that we all depend on in our daily lives, from energy and metals to water and many others. In this season of the podcast, we have already heard from Stefan Basenach, Senior Vice President of Process Automation Technology at ABB, who told us about the evolution of industrial automation. Starting from the 1800s, Stefan outlined the period when machines first replaced human muscle, all the way to today's advanced systems that operate some of the most complex industrial infrastructures on the planet. And for this episode, we're zooming in on why it matters today as we ask the question, as demands for energy and materials grow, how does automation keep the world's most essential industries running safely, efficiently, and without interruption? I'm Fran Scott, and this is the Process Automation Podcast from ABB. We are going to be joined by Nico Duursema, CEO of Cerilon, and Sam Eklöf from Käppalaförbundet Association. But first, we are welcoming back Stefan Basenach, Senior Vice President of Process Automation Technology at ABB. Stefan, it's great to have you back. So automation, it is really important for industrial infrastructure, but why is it important to all of us?
It's everything that touch every day somehow goes back to an industrial plant. And what automation and control is doing, we make those plants running. So you could say without automation and control, our normal life wouldn't be like it is today. And just to give you an example, it's about steel, it's about plastic, it's about medicine. So everything roots back to something where automation and control was involved.
So Stefan, could you help us set the scene, right? Things have been working absolutely fine with industrial infrastructure. So why does the industry need to innovate in automation and control systems? What's changed?
Sustainable and regulatory requirements are getting more and more advanced. So they need to not just produce a product, but they also need to do it under certain conditions. Another thing that's getting more and more important is the workforce. Workforce is changing. We want to attract more IT-oriented people to work in the industrial plants, and their automation can play a very important role. And on the other side, you see this global competition, how economies and states are competing to gain the leading position in a certain area, in a certain field of industry. So productivity improvements is also part of the story every day for our customers. And their automation plays an absolutely crucial role to have those productivity gains and at the same time improving the quality of the product, to make it more flexible, to make it easier to use, make it adaptable to new requirements. And finally, what we tend to underestimate is the kind of flexibility requirements those plants need to handle today. When we move away from fossil energy, which is a huge energy storage, to renewable energy, we need to accept that the energy will be far more volatile. If you have sun and wind, you have tons of energy. If you have no sun in the night and no wind, you need to use energy you stored before. And this kind of additional volatility is really a totally new challenge, which is the result of the energy transition. So there are tons of things needs to be considered that our customers can handle the future in the best way.
So there is this need to innovate within the industry and within infrastructure, and they are doing that, I know. So what is holding those that aren't doing it? What is holding the industry back of putting all of these marvelous systems into practice?
We are an enabler technology. We are not the main purpose of our customers that they run automation. Their purpose is to build their product. So at the end, they have this kind of one idea, automation should run forever because I only want to produce my product. That's my main focus. On the other side, they're seeing this big challenges and potential improvements. And for that, they need to innovate. So they have this kind of need to find a balance between keeping things stable to produce their product. On the other side, investing, changing the automation to gain the benefits of this new technology. And this is a continuous negotiation which happens between us and our customers. And what we also need to consider, some of our customers, they only can stop their plants every 6 to 7 years. So they're running 24 hours, 7 days a week, during Christmas, during Easter vacation, whatever, because we want to have, for example, electrical power in our house, in our housing. We want to have heating in our housing, etc., etc. So that means there's another kind of framing that when you innovate, you have to do it in a very short time, every 6 to 7 years. And this is also something sometimes can be a bottleneck.
Understood. And from, let's say, the control centers that I visited throughout my career, a lot of them seem to be about 40 years old. You know, you look at the computers and you're like, gosh, these are from the 80s, 90s. How are companies refreshing their systems?
We see a lot of stepwise innovation. And that makes, in my view, absolute sense. What customers really want to avoid is what we call rip and replace. So like you would do it today in your household, get rid of your old washing machine and just buy a new one. This doesn't work for complex plants. So we need to offer innovation in a way that you also can connect it to more legacy parts of the plant the customers don't want or is not able to renovate at that time. If they continuously do the efficient things and innovate at the right aspect, which brings them value, I think then they have a good strategy.
And Stefan, could we zoom in a little bit more on this? Because when we're talking about innovation in automation and control systems, what technologies and trends within those are making the biggest differences?
Yeah, Fran, there are many. Let me pick two. So the first one is this continuous exchange of data. In the old days, the strategy was to put the data behind the fence of the plants because people wanted to be secure that there's no intruder is able to enter the plant. So therefore, we need to change this attitude and making the data available because you want to use all this AI-driven algorithms to really add customer value. So we need to innovate automation in a way that data exchange is possible without diluting the cybersecurity level. This is one very, very important technology trend. The other one is the split between software and hardware. Today, the software and the hardware piece is very closely linked, although both have a different life cycle. So hardware can run 25, 30 years, and software is asking for faster innovation. Just think how often you update your phone. And that shows pretty much the difference those two life cycles have. So what we are working on to make this dependency less stringent, that customers gain more flexibility in that topic.
And this makes sense. This makes sense of why you go into a control room and the hardware looks dated, but it's actually running up-to-date software because of their different life cycles. And what you're saying is, yes, at the moment, they are in a way reliant on each other, but in the future and happening now, they are being decoupled so you can continuously make that hardware work more efficiently just by updating the software.
And the decoupling is again not a technology issue. The decoupling serves the customer value to get more flexibility. And it's a beautiful picture of innovation with continuity. So you want to continue using the hardware by continuously innovating the software piece. So this is a perfect example what we mean with our measure innovation with continuity.
And in light of all of this innovation that's happened and that has sped up over the last few decades, how has the implementation of this automation innovation affected those actually working in the industry and what it's like to work there?
A very good point. And let me try to explain with two examples. So let's assume you are in a large industrial plant and you want to exchange a pressure transmitter. That's a device that measures pressure and send it via a data connection to the control room. In the old days, the operator, the person in the field needs a lot of knowledge to do that. And he needs to have exactly the same device available to make this replacement. What is already possible today is that the exchange of this device is very simple. You can take any device that measures pressure. You can replace the defect one with the new one. The software will ensure that this device gets all the information from a central place, so it will remotely be configured, will be tested, and if all works, connected to the control application. So where in the past time you need to do a lot of manual steps with a lot of knowledge, in the future, you can do that far more pragmatic, much safer, and the data quality will be always 100%. This is one example. Another example, going more into the AI area, if an operator sits in front of the screens running a plant and he feels this is a difficult situation, he just has a kind of gut feeling, this is not working well. We have a technology where he can say, did I have this situation before? And then AI will run into the legacy of the data and potentially find those similar situations. And the software will give him, in those earlier occasions, you did that and that with that success or failure. So the software can help the operator to learn from the past instantly when he's sitting in that situation. Those are two simple examples how technology will change the way we operate those plants, will change the way how people have to work in those plants. To the better, in my view.
Stefan, that's so well described. And I kind of hadn't thought of AI being used as this institutional memory that can be provided at a touch of a button to a new worker. But I suppose that solution to that individual worker only is available because it's part of a wider technology ecosystem, right?
Yeah, that's the part where you only can get the full benefit of those new solutions by also making your automation system, your ecosystem up to date. So it doesn't come for free. So you cannot run a 30-year-old control system and then expect it to be latest status of artificial intelligence. And this is a kind of balance the customer needs to find to gain those benefits by doing the right investment at the right place.
So when we talk about automation and control systems, in what particular industries do they have the most change that we see?
The biggest change is really the energy transition journey our customers facing. When you today have an industrial plant and you're using fossil energy for heating, they have the task to replace all this fossil-based energy transformation to heat towards an electrical-based system. And this is a big change. You can go to cement industry, to steel industry, refineries, chemical plants. All those plants need to introduce electricity as the main primary energy. And this is really the big change. They need to handle the next 10 to 15 years to get our societies net zero.
Thank you so much, Stefan. Next, we have Nico Duursema, CEO of Cerilon. And Cerilon is developing a new industrial facility in North Dakota in the US, where automation isn't just a tool, it's a foundational element that is going to help this gas-to-liquid plant stay future-forward for decades to come.
Cerilon's vision is to be a leading energy transition company. So we've got an unwavering focus on sustainability, our partners, our communities, and the people that we work with.
And could you tell us a bit more about energy transition as a platform to meet the increased demand? And for listeners that might not be that familiar with it, could you walk us through the gas to liquids process, please?
Gas to liquids is taking the clean natural gas and converting that into high-value products. We've added carbon capture and sequestration, or CCS, and this will make it the lowest carbon footprint gas-to-liquids facility in the world. Now, doing this, you also transform that into high-value products. Now, the products that we generate from clean natural gas is ultra-low sulfur diesel. We can make kerosene or jet fuel. We make naphtha. And then we make synthetic lubricant feedstock called base oils. So it is really high-value products. The beauty of the products are that they're biodegradable. You've got long storage capacity, and that means longer than 5 years. So that is useful for defense applications. We also then, have the benefit of a very low, NOx and SOx emissions profile.
And when you say NOx and SOx, that's nitrogen oxides and sulfur oxides, isn't it?
Absolutely, yes. Yeah.
And this plant that you're building is obviously designed to operate for decades to come. And so what specific steps are you taking to ensure that it is future-proofed? And what is the role of technology in ensuring that that does happen?
I want to widen your perspective a bit, because it's not just about the facility, it's also about the business. Our premise is where we're looking at, running a future business. You need to be able to have an adaptive and learning organization that accommodate all the main changes that we see today. The facility itself should be adaptive enough that I can accommodate different qualities of feedstock to provide the same quality of high-value products in the end. So what we've done as a fundamental piece in the structural design and the philosophy of designing the business, as well as designing the facility, is accommodating adaptive and learning organization principles with a systemic design, looking at how do we look at the business, and then how do we look at the operations, and then integrating both of them. Now you're adding to that and say, how do we do that with technology? Technology is going to improve and it's going to change. So our adaptive approach is looking at creating a plug-and-play platform. So utilizing the ABB platform as a basis for operations, we then, as newer technologies are generated and developed, we can include them and adapt to it, because we've already set up the integration capabilities, how we actually combine it, and how do we approach it from an integration and then an operational perspective.
And how could specifically automation help with this future-proofing?
Automation has got two types of roles. On the way we're looking at our business is really to looking at the growth side as well as the optimization of the current business and facilities. The automation processes is being evaluated for what they are today, how we can then grow the processes and hand them over to be an automated process over time. In doing so, we're creating a platform that the automation will have a continuous process as we migrate from current, human interfaced processes to automatic as they prove themselves, in the course of time.
And so, as well as automating the processes, you're also automating the improvement of that automation, because of course automation is continually developing, isn't it, and enhancing. And so specifically, how would you make sure that your plant stays up to date with these innovations?
We've looked at the different technologies and the design of our platform. We utilized the plug-and-play concept. So as technologies are improving, we would then have the ability to say, I'm going to analyze this. Will this add value? And as we evaluate those, we then can either then decide to integrate it or phase it in, but then, have the ability to migrate to a better version than we were before. And it's part of the ongoing growth and optimization that we do. And as technologies will improve, that will be incorporated. So it is really about the platform, the way we've set it up, and the mindset of knowing that we don't have the full answer, that is going to materialize in, 10 years or 5 years or 20 years from now.
And so in terms of making this plant that's fit for the future, technology, of course, is one part of it. But how are you making sure that it's fit for the next generation of workforce?
For each piece of equipment, each system, and each condition that you're facing, there are sets of competencies and capabilities that you require, whether it's from an operator or a supervisor or a maintenance person looking after this piece of equipment. And in doing so, we then, with this adaptive mindset, can look at what are the competencies and skills that we need to do each of those activities. And as we then learn more about newer equipment, newer maintenance philosophies, whether it's predictive or others, and how do we then embrace that as part of a development path, we can then go back, because we're looking at an integrated business and operation, we can then future looking at what are the future capabilities and competencies that we need. And as we develop that, we can then start intentionally train and develop people before those capabilities are acquired. A very good example today is how do we create AI capability and to change people in mindsets of how AI can be a companion and a support rather than a threat. And that is part of future capabilities that we need to acquire.
And so with everything you said, in terms of having this adaptive framework to make sure that you can be agile for the future, wherever the future might take you, are you excited about the future of this industry?
It is an amazing privilege and time to actually be in business and in this life today. Because of that convergence of, environmental changes, technology that is available, as well as the community and society side, that convergence is creating something extremely beautiful. It is absolutely a time for, people that embrace complexity, embrace this rapid, mode of change. And, for the people that can embrace this to the levels that we don't even understand today, it's going to be an absolutely amazing time.
Thank you, Nico. Energy is absolutely fundamental for our society to grow and thrive, but so is another precious resource: water. We are now joined by Sam Eklöf, an automation engineer from Käppala Association, a wastewater treatment company in Sweden, to understand how they have been using automation in their operations. Käppala has been operating its underground treatment plant for over 56 years, serving more than 500,000 people across 11 municipalities. We're here to find out how automation keeps this essential service running and how it helps Käppala meet rising demand, tougher environmental standards, and the reality of aging infrastructure.
The plant, it's fully automated and runs every hour all year round, and has been doing that since it started in 1969. And we have around 12,000 objects that are supervised and controlled by our control system. And that could be pumps, valves, instrumentation, HVAC systems, everything in the plant. But also the HVAC systems in our office areas and conferences room.
HVAC being ventilation systems.
Yes, exactly, ventilation systems.
Following on from that, what advantages does the automation give you? What do these systems allow you to do that just wouldn't be possible otherwise?
Well, these systems, they are very good at performing repetitive tasks, and they do it quite rapidly and at a scale. and often 24/7. And scaling up with people alone, that becomes just unsustainable. It's not possible. So the automation and control systems, they allows us to do more and faster with fewer errors at lower long-term costs and in environments unsuitable for people. And we can maximize real-time data for smarter decisions.
Absolutely, because let's not forget that we're talking about wastewater here. So something that perhaps humans, we shouldn't be going too near, but something that we all need to be processed as a society. And so, yes, that automation, it provides the accuracy, the efficiency, but also the safety.
Exactly. Safety is important because if the plant would not be running, it would, it affects the environment, of course. But as you all know, waking up in the morning, using our toilets or taking a shower, using our washers and dishwashers, and we just need them to work.
And so what are some of the challenges that you've got to overcome when it comes to making automation within a plant like this a success?
If you take the control system, it's there are both the hardware parts and the software. Both of them are kind of off-the-shelf products. There is no one-size-fits-all, so you really need to customize it for your needs. So you need to plan your system and how to build up your system, from everything to hardware to libraries and applications. You need to plan on how to set up your networks, communication to switch gears and drives and instrumentations and such on. And then legacy systems, we often rely on old, outdated systems. So you need to have a plan for maintaining and upgrading your systems at all time. That is quite important because old systems, they don't really talk well with new systems. And then, of course, there's coordination with other departments, such as electrical, mechanical, IT, and then the persons who knows the process.
That's such an insight, Sam, because naively, I thought the challenge would be actually physically getting the device into its location within a plant like this. But what you're saying is that the challenge is actually looking at the lay of the land and trying to understand the problem as a whole, and then trying to use standardized equipment to overcome that problem, and doing it in a way that's efficient and works for the team, all whilst keeping the plant operating. And something that we've covered a lot on this podcast is the need to balance innovation with the necessity of maintaining continuous operations, especially for something like this. So what's your take on all of that?
Well, I agree that it's a really good question. And we also work with balance in many ways. For an example, we have the technology to treat the wastewater to a really high quality products, but the challenge for us is to treat it good enough. We must balance the operations with consideration for what is economically and environmentally sustainable, because we could maximize our use of chemicals, and that would result in cleaner water leaving the plant. But at the same time, it would also cost us very much money and cause emissions from production and transportation of bulk materials, and also cost a lot of energy. So we need to balance on how do we treat the water? Do we treat it extremely good, or do we treat it well enough?
Yeah, because you would think you've got to treat it as well as you possibly can, because that's what would be the best for the environment. But you're saying the equation, it's not that simple, because making the output more environmentally friendly might actually involve a process that's less environmentally friendly. And how does working with technology partners help you to integrate the new systems with the old ones?
I would say that I am good at what I do, but I don't know everything. So that is the main part. You need to accept that if you want to have the best knowledge of the systems, then you need to ask someone for it, and that is what we do. We are good at having the overview of our systems and having the right knowledge that we need to design our networks and stuff. But when it comes to the really hard parts of the systems, we ask the real experts.
So looking forwards to your future at Käppala, what technologies do you think will have the biggest impact on automation in the next 5 to 10 years?
That is a good question, and I think it's a tough one, because I think that it looks quite different between different industries. So for Käppala, we have been working quite long with a digital twin for virtual commissioning of application codes. And that's one thing that we've been talking about for many years, and now it's finally happening. And our digital twin is a cloud solution, and it's a copy of our production systems that we connect to a simulation software, and it simulates all hardware. And then we can use a Bolt Data Manager tool to export lists of process objects and using templates to automatically generate the simulation application. And then there is basic modeling in this simulation software. And if you want to do more complex modeling, we use Simulink for that.
So when you say virtual commissioning, is that when you install a system virtually in a digital twin and then see what happens? And I suppose that digital twin, it helps you practice without the pressure of perfection.
It allows us to do testing, application testing, much earlier in the process. So we can do all the testing before the plant even is built, or maybe at the same time as it is built. So we can save a lot of time and hopefully a lot of money. But I think that in industries in general, we're not that famous for embracing new technology. We are a bit skeptical and we take our time. And I think that it's because we have invested a lot of money in these systems, and we want them to be running at all time. It's crucial that they run at all times. So there's the balance in always keep the systems running and keeping them really fresh and new.
All of this just goes to show that automation, it's not a nice to have. It is essential, especially when it comes to our infrastructure to keep our society thriving, running day to day. But that is it for this episode. Of course, a massive thank you to our guests today, Stefan, Nico, and Sam. I'm Fran Scott, and the Process Automation Podcast is a Fresh Air production for ABB. Follow now for free wherever you get your podcasts so you never miss an episode.